We're going to continue to look at similar polygons and applying similarity. In example 1, it says the hexagons are similar. So what we've said in the past is if shapes are similar, then that means they have they're the same shape but different size. Same shape, different size. And so we're going to apply that here. We have two similar hexagons. This one's bigger than this one, but we know that all the angles would be congruent, and that would make them similar, so we could set up a ratio or proportion. So now we just apply the ratio to the similar side. So we could say 20 over 8 equals x over 6. And then we can solve for x. Multiply, 20 times 6 is 120, equals 8x. Divide by 8, 120 divided by 8, would be 15. So x equals 15. Then we solve for y, and we do the same type of proportion. We can use 20 over 8 again, and that equals 15 over y. Just got to use the corresponding sides. Cross multiply, 20y equals 15 times 8. We just did that, 120. Then you divide by 20. Y would equal 6. I'll just write it here. Y equals 6. But that's applying similarity, and that can be used for any type of polygon. Now let's look at one more theorem here and take it one step further. Theorem 44-1 says if you have two polygons that are similar, then the ratio of their perimeters is actually equal to the ratio of their corresponding sides. So over here it was a similarity ratio of 20 to 8. I could reduce that and say 2 goes into 20, 10, 2 goes into, actually I could say 4 goes into 25 times 5 over 2. So that'd be my ratio. That was the ratio of sides. But what theorem 44-1 tells us is that is also the ratio of perimeters. So if you know the ratio of sides, then that is going to be equal to the ratio of the perimeters, or vice versa. So now let's look at example 4. It says figure HIJK and is similar to LMNO. I'm just going to draw these. It doesn't show a picture, but I can help you see it a little bit better. HIJK, LMNO, and it says they have a ratio of 2 to 5. So we'll just say one side over here is 2 and one side is 5. So if that's our ratio, and then we know that HIJK's perimeter is 27 inches. What is LMNO's perimeter? Well, what we can do is apply this ratio and say, okay, this one is referring to HIJK, this one is referring to LMNO, and so over here I'm going to do the perimeter of HIJK, and that is 27, over the perimeter of LMNO. I'm going to call it X rather than write all 4 of those letters. But here's the ratio side, and here's the perimeter side or column. And then you cross multiply and solve. So 2 times X, 2X, 27 times 5. Plug that in your calculator, and you get 135. Divide by 2, and you get X equals 135 over 2. You can put that in decimal if you want. But the perimeter of LMNO would be 135 over 2. Whatever the measurement is, inches. And so that's how you apply similarity to polygons when it is referring to perimeter.